Hi, so this is an addition to the periodic trends for electron affinity. This is a newer one for our standards, so I just am adding it on as a separate standalone all by itself. Now it's like ionization energy, but in ionization energy we're talking about becoming a positive ion, therefore losing an electron. This is for gaining an electron. So as you can see with the nonmetals, which gain electrons to become ions, you can see they have some of the highest electron affinities. While in the middle you have your transition metals, which are kind of transitioning from the alkali and alkaline earth metals to the nonmetals, while you can see our regular alkaline earth metals are the lowest possible because they really don't want to gain any electrons. So when the atoms are smaller, they have a higher attraction to their electrons. So if you're going to gain an electron, this actually releases energy in the fact that it becomes more stable. So in that huge release of energy, we see our halogens, number 17 over here, has the highest, because if they gain one more electron, then they become like the noble gases. So because the atoms are smaller, they have higher electronegativities, and so that means their ability to gain electrons is far higher, so when they do, they release a lot of energy. As you go down the periodic table, meaning from period 1 all the way down to 6 or 7, then you see that they get larger, and so that attraction is less, and because that attraction is less, the energy released is less when gaining an electron. This is a way to summarize the trends differently. I still want you to be talking about on your test and going forward as you go down a group and as you go across the period. If you give me something else, I'll send it back to you and you'll have to do it all over again. So this is a way to remember them, but when you're reporting them, talk about the period trend going down, and I should say that's the group trend, and the period trend across. But these are some other ways that you can think about understanding these ideas, which is what you should also be doing in chemistry, is rewording, rethinking of how we can interpret this information in your own right. Come in with any kind of questions. See you soon.